All right, let's go ahead and just talk about the first page. We'll go over any questions you have on 1 through 6.
Number 5.
All right, number 5 says the function f of x equals tan 3x has 1, 0 in the interval 0 to 1.4. The derivative at this point is. Okay, so obviously first we got to graph that function. Here, let me tell you guys this thing really quick, by the way. Okay, and this might be a good idea, and it'll certainly save you some time on the AP exam. But if you can see my calculator here, hopefully, it's coming. Hold on just a sec.
Good morning, teaching students. Please pardon this interruption. Student, if you have a testing pass, please make sure you are reporting to that location at this time. Once again, students with a testing pass, please make sure you arrive at your destination at this time. Good luck and thank you.
All right. So what I was going to say is, if you see my calculator here, in Y2 and in Y3, I have pre-typed in Y2, find the derivative of what's in Y1, and in Y3, find the derivative of what's in Y2. Basically, this is your first derivative, and this is your second derivative. If you do that, not necessarily all the time, but it will certainly help if you do it right before the AP exam to have that in there. It will save you a little bit of time because you won't have to type that every time, especially typing in the actual equations every time. All right, so let's get to number 5. The function f of x equals tan 3x. Oh, by the way, before I go away from that, make sure you have them turned off if you're not using them. So to turn them off, you're just going to have it look like this, okay? And then when something is on, like I'm about to type in number 5 here, tan 3 to the x, your equal sign is highlighted, and that means it's going to be on. Okay, so right now Y2 and Y3 are off. I'm not going to see those derivatives. All right, so number 5 says we have the function tan 3 to the x has a 0 on the interval 0 to 1.4. So obviously I want to change my window so I only see 0 to 1.4. I don't want to see anything else. So I graph it. And it looks like this. And the next thing I need to do is I need to find that 0, that x-intercept right there. Okay, so we know it's somewhere between 0 and 1.4. So I'm going to hit second trace, option 2. And then from there, you can move your cursor, or you can just type in a number. I type in numbers, so I'm going to type in left bound 0. Excuse me. Right bound 1.4 and hit enter. And then when it says guess, just hit enter again. Okay, and my calculator tells me 17.57 something. And I'm actually surprised that that is not one of your answer choices on this question, because it's common to just go, oh, there's my answer, now I'm there. Okay, oh wait, I didn't hit guess yet. That wasn't it. There we go. At 1.04. Is that one? Yeah, that one is on there. Okay. All right. So it tells me that the 0 is at 1.042, and that is one of your answer choices. That's a common mistake. Okay, because the question is not asking for the 0; it's asking for the derivative at the 0. So I'm going to write down really quick that my 0 is 1.041978. And now I'm going to find my derivative at that point. Okay, so in my calculator, from the graph, I can find my derivative. I just hit second trace, option 6, and I type in that number, 1.041978. And it's going to tell me the derivative is 3.451, which is answer choice C. All right, I'm gonna actually move my calculator a little closer and not worry about the paper here. So you can read my screen. All right, any other questions, 1 through 6 here?
Maybe,
Which one?
May you do 6?
6?
Yes.
All right, so number 6 is telling you, 1 second. All right, number 6 gives you a mass function, and it says, what is the average rate of change in grams per week during the 5th week of growth? I'm actually going to switch back over to this really quick, okay? So average rate of change is slope of the secant line, okay? And it's saying that it is during the 5th week, okay? So during the 5th week is from week 4 to week 5, okay? So our interval is 4 to 5. And so the average rate of change is m of 5 minus m of 4 over 5 minus 4, okay? And I'm actually going to show you a trick. So obviously the first part is you had to understand this interpretation, okay? We know 1's in the denominator, 5 minus 4 is 1, but we got to find the numerator. I'm going to show you how to find it in your calculator a little faster, okay? So I'm going to go back into y equals. I'm going to clear out my y1, and I'm going to type the mass function into my y1. Okay, so it's x e to the x over 80. Okay, that function is in my calculator. That's the function I am currently working on. Now, there's 2 ways I could do this. I could go to my table and I could find the value at 5 and the value at 4. Okay, the value at 5 is 9.2758. The value at 4 is 2.7299. And I can subtract those 2 numbers. Okay, I write them down off to the side. I go type them into my calculator and I can do that. But there's another way you can do it. Okay, you can actually type into your calculator. It's not the exact variables, but you can type into your calculator m of 5 minus m of 4 by simply typing in y1 of 5 minus y1 of 4, because y1 is our function, whether you call it m or f of x or whatever. Y1 is our function. Okay, so on my home screen, just like I can type y1 into anywhere else, if you hit alpha F4, you have a list of y1 through y10. Okay, well, I want to do y1 of 5. And so I just type it in like that, minus y1. So I go alpha trace again, y1 of 4. And it's going to give me that answer. So instead of actually looking up the numbers in the table, writing them down, then going back to your home screen and subtracting those 2 numbers, you can actually do it with the calculator and not have to type them in. And then that's obviously over 1. And so the answer is D. I think the hardest part of that problem was probably understanding that my interval was from 4 to 5. All right, anything else up to 6?
Can you do 1, please?
Uh-huh. All right, so there's 2 ways to do it. You can graph the function, and then from the graph, do the derivative. Okay, so you're in y equals, you have a graph. This is not going to be the right graph, obviously. It's just some graph. It's graphing slow. All right, there we go. And then from there, you would go second calc or trace, and you would pick option 6. Okay, another way to do it is to do it on your home screen. From your home screen, okay, it's math, and it's option 8. Okay, so I'm going to find the derivative of x cosecant x at pi over 3. So I'm going to put an x here. And then for my function, we have to remember that cosecant's partner is sine. It's the reciprocal of sine, right? So cosecant is the reciprocal of sine. So it's going to be x at times 1 over sine. And instead of writing times, I could just say divided by here because it's just one function. So I could say x divided by sine x. And then over here, I'm just going to type in pi over 3. And I should get 0.457.
Mr. Masson, on number 6, why was the interval 4 to 5?
Okay, so they're saying, what is the average rate of change in grams per week during the 5th week? So during the 5th week is the 4th week just ended, and now I'm starting the 5th week. Okay, so like week 1 is obviously the first 7 days, but you haven't done a whole week yet, right? Because on day 2, you're still in week 1, right? So your interval on day 2 is from week 0 to week 1. So your interval for week 5 is week 4 to week 5. Because on day 1 of week 5, you're really just past you're on the first day, or you're just into the next interval of right after the 4th week. Does that make sense?
Yeah.
All right, anything else on page 1 there? All right, let's go to numbers 7 through 12.
Can you do number 8?
Uh-huh. All right, number 8 says f of x equals 3e to the 2x, g of x equals 6x cubed. At what value of x do the graphs of f of x and g of x have parallel tangent lines? Okay, so the interpretation of that is, tangent lines are from derivatives, right? Okay, so it's really saying, when does f prime of x equal g prime of x? Okay, that's what it's saying, because at what value of x do the graphs have parallel tangent lines? Okay, well, tangent lines mean they have the same slope. Okay, and same slope means the derivatives are the same. Okay, so what I want to do is I want to graph this function in my calculator. I want to graph this function in my calculator and graph their derivatives. Okay, so here's what I'm going to do. It's a little funky in my calculator. Okay, in y1, I'm going to graph f of x. So it's 3e to the 2x. And in y2, I have the derivative of that already put. Okay, I'm going to turn off my y1 and turn on my y2. Okay, that's the derivative of f of x. Unfortunately, I have to do a little more work to do the second one. So I'm going to go down to y4, and I'm going to put in g of x, which is 6x to the third. And in y5, I'm going to put in the derivative of that function. So in my calculator, it's math, and then it's option 8. And so it's the derivative of y4. So I'm going to hit alpha trace, pick y4, and then I'm going to put an x right here. Okay, I'm going to then turn off y4, because I don't want to see 6x cubed. I just want to see 6x cubed's derivative. Okay, so don't look at my y3, pretend it's not there. y1 is f of x, y2 is the derivative of f of x, y4 is g of x, y5 is the derivative of g of x. So I have my two derivatives that I'm going to see, and I want to know when they're equal. So I graph them now. I got a bad window probably. So it's a bad idea here. It's going to take a while to graph these two things. Probably just smarter to turn it off for a minute. Let me get a better window. All right, hopefully this is better. All right, here comes the first graph. Kind of hard to see probably, but there's the graph of the derivative of 3e to the 2x. And then the other one should be a quadratic function. The derivative of 6x cubed is going to be 18x squared. It should be coming here any second. And we just want to find where they intersect. Here it comes. Okay, they intersect at this point right here. Okay, it's pretty obvious that that x value is going to be negative where they intersect. And unfortunately, all 5 answer choices are x values of negative. So we have to do some more calculator work. We have to find the intersection point. So it's just go to second trace or calc, and that's where we're going to find all these things in y equals. And we want to know where they intersect. So we're picking option 5. And then it asks you for the first curve. My cursor's on Y2, but that's fine. I hit enter. My cursor jumps to Y1, or excuse me, Y5. That's where I want to be. I hit enter. And then you don't really have to guess unless there's more than one intersection. So let's say they intersected twice and it wanted a specific interval, then you would have to guess and you can move your cursor. Like for example, if you can see it, I'm going to move my cursor closer to that intersection. They intersect right about here. And so I've moved my cursor a little closer to that. I hit enter. And then eventually it tells me the intersection right here is at, and it asks for the X value, negative 0.3906, which is C, negative 0.391.
How are those parallel tangent lines though?
Okay, they're not parallel tangent lines because I didn't draw them. Okay, I could draw in the tangent lines at those 2 points, but I don't need to in my calculator because it's not asking me for the actual equation of those tangent lines. It's just asking me at what point will we have parallel tangent lines. Okay, so both tangent lines are going to go through that point of that graph. Okay, does that make sense?
Yeah.
Okay, so you're not always going to see what you're finding, right? We're just finding the tangent lines are parallel. Tangent means slope, right? The tangent line is the slope of the derivative. So it means when the slopes are the same, because parallel lines mean same slope. So same slope, just all we're doing is finding where they have the same slope. Okay, we're not finding the actual tangent line or anything else.
Okay. Could you also do 11, please?
Uh-huh. All right, so number 11, for what values of x in the interval 0 to 2 is the slope of the line tangent to the graph equal to the slope of the line joining these 2 points, okay? So let me just pull my paper up really quick here. Okay, I need to find the slope of the line connecting these 2 points. So what that really is saying is the average rate of change, right? That f of 2 minus f of 0 over 2 minus 0 is the average rate of change. This is a mean value theorem problem, by the way, okay? It's asking for when the slope of the tangent line is equal to the slope of the secant line. That's a mean value theorem. Okay, you could either do this in your calculator, or since we got a 0 here and a small number and it's a polynomial function, we could probably just do it in our head. Okay, first of all, we know 2 minus 0 is 2, so that's in my denominator. F of 2 is plug a 2 into this. Like I said, I'm going to do it in my head. 2 cubed is 8. 2 squared is 4 times 3 is 12, and 8 minus 12 is negative 4. So this is going to be negative 4 minus f of 0 is 0. Plugging a 0 into that, we get 0. So negative 4 divided by 2 is negative 2. That is the slope of my secant line. The question is, when is the slope of the secant line equal to the slope of the tangent line? So it's asking me, when does f prime equal negative 2? Okay, and there's several ways to go about doing that. Okay, and that's a y value, not an x value. Okay, when does f prime equal negative 2? We have to find the x value. Okay, so I'm going to go back into my equals, clear out this function, go down here, clear out this function, turn y5 off, or wherever you had it. I need the derivative of x cubed minus 3x squared. Okay, and obviously you could do that in your head and you could just type it in. Okay, but I'm just going to type in x cubed minus 3x squared, and I need the derivative of that. Okay, sorry, I didn't have my calculator up there. I need the derivative of that. I don't want this function, so I'm going to turn y1 off. The derivative of that is in y2. And the question is, when does my derivative equal negative 2? So I'm going to draw the horizontal line negative 2, and where that horizontal line intersects my derivative is where the slope of the tangent is equal to the slope of the secant. Okay, so down here in y4, I'm just going to graph negative 2. The first graph you see pop up is going to be the derivative of x cubed minus 3x squared. Okay, it's a quadratic. there's the derivative of the x cubed function. And where that derivative equals -2 is going to be my answer. So here comes the line -2. So as you can see, in the interval 0 to 2, so we're just talking about from here to here, okay? It appears that we intersect that graph twice, which means that the derivative is equal to -2 two times. And now I can see that of all my answer choices, only one of my answer choices has two different answers. But we'll verify just so you guys can see it. I need to find where these 2 points intersect. Okay, so I'll just find the one on the left first. Second calc option 5. And it says first curve is the derivative, second curve is the line, and it asks me to guess. I have two different ones here, so I'm going to move my cursor right up next to this intersection point right here and hit enter. And it tells me that that one is 0.4226. Okay, right there, 0.4226. So that's one of them. Okay, so 0.4226 is 0.423. Now you'll notice that that is an answer choice all alone. And obviously you'll notice that 1.577 is also an answer choice alone. Okay, but it happens twice in the interval 0 to 2. And to find that other one, we would do the same thing. Second calc, option 5. First curve is y2. Second curve is in y4. And it asks me to guess. I need to move my cursor closer to that point right there. Okay, so my point is right here. I'm going to guess now, and it's going to tell me it's at 1.577. So the tangent to this graph is equal to the slope of the secant in two different places at 0.423 and at 1.577. I'm going to guess that it's more of interpreting what you need to know or what they're asking you than it is a calculator problem. It's going to be said to you all year, that's the hardest part of calculus, okay? Almost all the work is algebra. And I know you guys are all good at algebra. It's just a matter of what are they asking me? All right, any other questions on 7 through 12?
May you go over 10?
All right, number 10. The minimum value of the slope of the curve y equals x to the 5th plus x cubed minus 2x is, okay? Now, don't think you got to check all these numbers, okay? First of all, they're asking for a minimum, right? What's that word right there that I'm underlining?
Slope.
And what is slope?
It's just a derivative.
It's just a derivative. So it's asking me for the minimum value on the derivative. So in number 10 here in y1, okay, I'm going to go to y1 and I'm going to type in that function, x to the 5th plus x cubed minus 2x. I don't want to see that function. I want to see its derivative. So I'm going to turn off y1. Y2 is on, and I'm just going to clear out y4 because I don't need that line -2 anymore anyway. So I'm going to just clear that out. And so now I'm going to graph y1, not look at it, and look at y2, which is the derivative. Okay, and the derivative of that x to the 5th is going to be some quartic function. Here it comes. And then I'm just looking for its minimum. All right, so there's your graph. Find that minimum point in your calculator. So second calc. Oh, it's still graphing. All right, here we go. Second calc. Option 3 is minimum, and my minimum is somewhere here. You can either move your cursor left and right or pick numbers. It's somewhere between -1 and 1. I can see that. And I just hit enter on guess, and it tells me it's at -1.99999, okay, which is -2. Answer D. All right, any others on this page? All right, let's go over to 13 through 18.
Can you do 16?
Yes. All right, 16. How many points of inflection does the function f of x have? Okay. Points of inflection are where the second derivative is equal to 0 and changes signs. Okay. So I'm just looking for, I don't care where they are. It's not asking me what are the points of inflection. It's just asking me how many. So all I need to do is look at the graph and see how many times it crosses the x-axis. Okay, or the second derivative. Okay, so here's a time where my y2 and my y3 are going to come into play, right? So in y1, I'm going to type in the function. It's parentheses pi thirds raised to the x cubed minus 8. So it should look like that in your calculator. I don't care about looking at that graph. And I don't care about looking at the first derivative, which is in my y2. I care about looking at y3, which is my second derivative. Okay, so I'm going to do that. And I'm going to hit graph now. By the way, if you don't know this, and this might be hard because it's got to figure out the first derivative, then it's got to figure out the second and graph them. If you go to window, and you probably haven't messed with this very much because we always told you not to before this, but if you go to XRes and up this number to say like 2 or 3, it will graph it a little faster. Okay, so I'm just going to change it to 2. And you have to, every time you change your window, you're going to want to play with that now. Okay, obviously the smaller the number, the slower it's going to be. Okay, but if I hit graph now, it's going to graph it a little faster, and you can see it coming along through here. Okay, the problem with this is it's really hard to tell how many times it crosses the x-axis because it's so close, and we'd have to zoom in on all of this area. But there's another way to find out how many times it crosses the x-axis in here, and just go to your table. Okay, so if I go to my table, and I'm looking at some values, and I'm just going to go from -10 because that's what I'm looking at. All these y values right here are all positive. Okay, and then at some point, we cross the x-axis between -3 and -2. Okay, so we had a 0 in there. So f double prime was 0 and changed signs. Okay, and so now we're negative. And then watch what happens if we go a little bit further. We become positive right here. We're 0 here, and then we became positive. So we cross the x-axis again. So the answer is 2 times. Okay, it's not going to happen again. We're going to be positive the rest of the way down. Okay, and you can see we're getting bigger. And by looking at the graph, you can see we're never coming back down, right? So it happened 2 times in here somewhere, right? At 0, it happened, and then somewhere in there. Okay, so exactly 2 times. But the interpretation is you got to interpret the question first. Where do I have a point of inflection? I have a point of inflection where the second derivative is 0 and changes signs. Oh, wait, I need to go look at the second derivative. Okay, we don't need to make a sign table and find those points. That's not what this question is asking. It's just asking how many of them are there. Just look at a picture or a table in this case. All right, next one.
13, please.
13, mean value theorem. Find the value of C where the average rate of change is equal to the instantaneous rate of change. Okay, you want to know when f prime is equal to, sorry, I'll write this here, f prime is equal to f of b minus f of a over b minus a. That's just right out in your foldable. Okay, that's the definition of the mean value theorem, where f prime, instantaneous rate of change, slope of the tangent line, is equal to f of b minus f of a over b minus a, average rate of change, slope of the secant line. So the first thing I need to do is find the slope of the secant line. Okay. You could plug numbers into this, and I'm going to show you one more time. There's an easier way. Okay. So I'm going to go to y equals. I'm going to clear out my y1, and I'm going to type in this function. So I am going to use my fraction button here because I got a fraction. And I have 2x in the numerator. And I have x squared plus 1 in the denominator. Okay, and I want that. I don't want to look at that function. I'm not even going to go to the graph, but I do need to turn off y3 because I don't want to see it either. Okay, that's my function. I'm going to go to my home screen first to find f of 1 minus f of 0 over 1 minus 0, because that's my interval. There's my a, there's my b. Okay, again, you could do this in your head if you want. Plug a 1 in, plug a 0 in. Okay, but I'm just going to have the calculator do it. So I'm going to have it do alpha trace, pick y1 of 1 minus alpha trace, pick y1 of 0. That's the same thing as doing f of 1 minus f of 0. y1 means f. And it tells me that that is equal to 1. So my numerator is 1. My denominator is 1. So it's 1. I want to know when the derivative is equal to 1. So now I'm going back into my graph. Okay, I want to look at the derivative. So turn y1 off. I'm going to turn y2 on because that's where my derivative is. And I'm going to look at the derivative. And I need to know when that derivative is equal to 1. But only, only in the interval 0 to 1. So you can see if I draw the horizontal line, y equals 1 right here, I'm going to cross there and I'm going to cross there. But this one on the left is not the one I'm looking for because I only want this one on the right because it's in the interval 0 to 1. So I'm going to graph the line y equals 1. Come find an open slot on your calculator. Graph that line. There it goes. And I want to find this intersection point because this is where the slope of the secant line is equal to the slope of the tangent line. Remember, these are not secant lines and tangent lines we're graphing. We're just finding the point. So I'm going to hit second calc, option 5. The first curve is in y2. The second curve for me is in y4. Yours may be different. And then the guess, I'm going to move my cursor because I have 2 answers. And so I want to be closer to the one on the right so it doesn't guess the one on the left. And then it guessed it, and it guessed it at 0.48588864. And 0.485 or 86 is answer choice B. All right, next.
Should you go over 17?
May you do 15?
Yep, I'll do 17 first, then 15. 17 says h of x equals, find the value of x where h prime is equal to 2. Okay, again, we're finding where our derivative is equal to 2. So we're going to graph a line y equals 2 and find out where they intersect. Okay. All right. So go back in here. My function is a new thing. So it's a fraction. So I'm going to pick my fraction bar. I got 3x minus 4 squared in the numerator. I got the square root of 2x in the denominator. And I want to know when that is equal to 2. So I'm going to, where the derivative is equal to 2. Okay. So I'm going to go down here into y4 and change that to be a 2. And then I'm going to turn my y1 off because I don't want to see I don't want to see f of x. I want to see the derivative, which is in my y2. And I want to know when they are equal. So I hit graph. The first graph coming up is my derivative. The next graph is my line y equals 2. I want to know when they are equal. So I find that intersection point. So I go second calc, option 5. I don't see my cursor, so I'm going to move him up so I can see him. There's, you need to see your cursor. So my first curve is in y2, hit enter. My second curve is in y4, hit enter. It asks you to guess. There's only one intersection here, so we really don't need to guess. We could just hit enter. and it found the point to be 1.534. All right, number 15 requires a little more than just calculator work. Okay, so number 15 is saying we have a particle moving along a line and we have its position function. What is the acceleration when the particle is at rest? That's two questions in there. Okay, the first thing is, when is the particle at rest? Which means v of t is 0. So I have to go into y equals, in y1, I'm going to put my position function, which is 2x cubed minus 9x plus 1. Plus 1. Okay. I'm going to turn off y1. I'm going to get rid of y4 down here because I don't need it anymore. Okay, and I want to know when my derivative is 0 or when my velocity is 0. My velocity is the first derivative, which I have graphed in y2. So I'm going to graph this, and I want to know when velocity is 0. Okay. Note it says when t is greater than or equal to 0, because my velocity is 0 twice. Okay, I only want the one on the right. So I'm going to find that point. Second calc, and that's a 0. So option 2. Again, you can move your cursor, but I can see that it's somewhere between 1 and 2. Okay, so I'm going to just type in left bound 1, right bound 2, and enter. And it tells me the answer is 1.225. Okay, I'm going to write that down. T equals 1.225. I'm actually there. Here's the one that I'm shocked on. I'm actually shocked that that's not one of your answer choices, because it might be common to pick that answer because you just got it in the calculator. But just because you got a number in the calculator doesn't mean you're done. The question is, what is the acceleration at that time? So now I'm going to go back into my calculator, turn off the velocity function, and turn on the second derivative, which is acceleration, and graph it. Now remember that we're not doing a derivative here. That is the derivative, the second derivative. We want to know what the acceleration is at this time. So I'm just tracing at this point. I'm not doing anything else but finding what the y value is at the time 1.225. So I trace at 1.225. Remember now, we rounded 1.225. And we got 14.7 there. Okay. Again, like I said, we rounded. So pick the number closest to 14.7, which is obviously answer choice E. If you want a more exact answer, then you need to make sure the number you write down this time up here, you write it down to a few more decimal points. Okay. Anything else on this page? All right, last page. 19, 20, and 21. Well, let's do 19 or 20 first. So if we have any questions on 21, we'll have the whole function typed in. So anything on 19 or 20, tangent line, right? For 19, that should be pretty easy. 20. Finding the
Can you-
velocity. Go ahead.
Can you do 20?
Yeah. Okay, we got a position function, and it asks us for the velocity at time t equals 2. So we're going to go into y equals. Actually, we don't even need to go into y equals on this one. We could do this from our home screen. It's just, when it's asking for the velocity at 2, it's just asking for a derivative. Okay, the derivative at 2. So I could do this on my home screen right here by going math option 8. I'll do this one this way this time because we haven't done this in a while. Okay, and x goes here. My function is going to go in here. So it's x cubed plus 22x plus 3 minus 6 cosine pi x. So typed in just like that. Close your parenthesis on that cosine pi x. And then it's asking me for the velocity at 2. So I'm just going to put in a 2 right over here. So the derivative of that function at 2. And we get 34. All right, 21.
Could you go back actually and do 19, please?
Yep, write the equation of the tangent line. Tangent line is, we're just going to graph that function and write the equation of the tangent line. So go into y1 and graph that function. Okay, so to get to the cube root button, you got to hit math, and it's option 4. So the cube root of x squared, clear that, x squared minus 1. Okay, I actually want to see that graph, and then I'm going to draw the tangent line. Okay, so I got to turn off y3 and graph that function. It's a funky looking thing we've never seen before, but I just want the tangent line at 3. So that's under second program or draw, right? Drawing a tangent line. So pick that option, and it's option 5. So I hit 5, and then I got to tell it where to draw the tangent line, and it's at x equals 3. So I just type in a 3, enter. Here comes your tangent line, and there's your equation right here at the bottom. Y equals 0.50000, so that's just 1/2 x. And then 0.49999, 1/2 x. If you wrote 0.499, you'll be fine, but it's pretty obvious that number's a half. The calculator is going to be slightly off sometimes. All right, 21.
Yeah. Can you do that, please?
All right, so I'm going to type in that function into my y1. That function is x squared e to the negative 2x. Okay, obviously, you know, we could do that one by hand. Okay, we know how to take the derivative of that. It's pain, right? It's a product rule. It's got a chain rule in it. Okay, it's got an e to the x. You got to have a memorized derivative. A lot of stuff going on in there. We don't want to have to do everything by hand. Okay. All right, so let me read the scenario. Particle moves along the horizontal line. The position, so this is our position function. Okay, and t is measured in seconds, x is in feet, although we were never asked to give units. The first one is find the velocity at t equals 1. Okay, that's going to be my second, my graph in y2, my first derivative. So turn off y1, turn on y2. Now, this is just one way to do it, right? Another way is you could just go to y1. Well, I'm going to do it that way this time, actually. Instead of going to my derivative, I'm going to look at y1, okay, which is my position function. So here comes the graph of my position function. It's already in there. And I want the velocity at 1, which means the derivative. So I'm going to go to second trace, option 6, which is derivative. When I get back to my screen, I type in the point where I want the derivative, and it's at 1. So I type in 1, and it spits out the answer. It's 9.022 e to the negative 8. So if we don't remember how to interpret that, 9.022 e to the negative 8 is the TI graphing calculator's way of saying times 10 to the negative 1. Okay? Or excuse me, it's 10 to the negative 8. Okay? That's the graphing calculator's way of doing scientific notation, which means move this decimal point 8 places to the left. What's the number 0.00000009022? It's 0. Okay, so the derivative here, f prime of 1 is 0. You can write f prime of 1 is 0 or v of 1 is 0. Okay, the derivative of position is velocity, or just write velocity is 0. All right, when is the particle moving to the right? The particle is moving to the right when velocity is greater than 0, okay? Or when f prime is greater than 0. So I'm going to go now graph my velocity function. Okay, I don't want y1 turned on, I want y2 turned on. Graph the velocity function, and then go find the intervals where you're positive. Okay. And if you zoom in, you will see that I'm negative right after 1. I'm below the x-axis here. I'm obviously below the x-axis here. It's from 0 to 1. Okay. But you just find that in your calculator. All right, let me just talk about the last two really quick. This one is asking you to find the acceleration. So you're just trying to find a of 1. Okay. And so just go turn on your second derivative, which is y3, and trace at the point 1, or you could go to y2 and find the derivative at 1. Okay, both of those work. And the answer ends up being negative 0.271. There was a typo on the answer key on this last one, D. It should have said A of 1 and V of 1. And A of 1 and V of 1 are right here. V of 1 is 0 and A of 1 is negative. We don't have the same sign. Therefore, we are decreasing. Okay. And actually, it was supposed to say t equals 2. I messed up that. I was supposed to change that, and that's why on your paper I forgot to change it. But the answer key would have been right if I would have changed that. So it doesn't matter which one you want to look at. But on knowing if speed is increasing or decreasing, you're checking to see if the signs of acceleration and velocity are the same or different. All right. Any other questions? All right, guys, we'll start something new tomorrow. It's Friday, and we're getting close to having our last test. I should be telling you next week when our last test is going to be, but we are going